Yeah. Now, in this session, I would like to show you how to run analysis of variance with replication. Now, we'll see how to run analysis of variance with replication. Now, go to data. Now, analysis of variance, two-factor with replication. Just click on. Now, select the data. And the rows per sample in two different variables. One is categorical variable, independent variable. Second one is continuous variable, which is dependent variable. When we talk about the independent variable, categorical variable, it is having three different blends. So three different blends, three different fertilizers. So each fertilizer and its sample is 50. So that's reason why rows per sample. So three different samples. So each sample and its count is 50. So totally three different samples, 53s are 150. Right? So anyway, here rows per sample are 50 because each blend comprises of 50 samples. And I have taken alpha value, a standard significant value at 5% level of significance, 0.05. And my output range will be somewhere here. I'm expecting my output range somewhere here, and just press click OK. When you press OK, see here, this is analysis of variance two-factor with replication. Okay. So analysis of variance two-factor with replication. Now see here, there were three different kinds of blends will come into the picture. This is the blend 1 and blend 2 and blend 3. So blend 1 stands for fertilizer 1, fertilizer 2, fertilizer 3. Three different kinds of fertilizers. Three different kinds of fertilizers. And four different kinds of, so four different levels of crop. So there were four different types of crops will come into the picture. The crop 1, wheat; crop 2, corn crop; soya crop; and rice crop. And comes to blend 1 and its impact on four different crops. If you see the four different crops, each sample size is 50, and its sum, the sum from wheat crop it's 6,958, corn crop sum it is 7,682, and soya crop 8,401. Anyway, the soya crop it is having some extent of high sum, and its average also high, and its average also high. And in fact, my hypothesis, there is no significant difference between type of fertilizer and yield of the crop. My null hypothesis. My alternative hypothesis is there is a significant difference between type of the fertilizer and yield of the crop. And when it comes to the blend 2, comes to the blend 2, there were equal number of samples, 50, 50, 50, and 50. And in overall, it is showing crop 2, corn crop, it is giving some extent higher results, followed by soya crop, it is giving higher results. Even sorry, the rice crop is giving higher results, followed by the corn crop, it is giving higher results, higher output, and soya crop, it is giving higher output. And the overall fertilizer 2, it's giving more output as compared to fertilizer 1. And when you go for the blend 3, the fertilizer 3 category, the crop 3, soya crop, it is giving maximum output, coming maximum output by using fertilizer 3. So it is being giving an evidence over here. The fertilizer 3 and soya crop, it is the best combination. Fertilizer 3 and soya crop, it is the best combination, because when you use fertilizer category 3 and the output from soya crop, it's all about 9,843. It is a maximum output. It is a maximum output, and its average also high. And its average also high. So in overall, if you can see, the output from soya crop is high. The output from soya crop is high. Okay. So when you talk about, when you go to the ANOVA table, the samples over here, the blend, the samples here, blend, the blend stands for fertilizers, and the columns here, crop. So I'm changing here. So my rows are blend. Blend stands for fertilizer. My columns are crop. My columns are crop here. So with respect to the type of fertilizer used, at 3 different kinds of fertilizers, fertilizer 1, fertilizer 2, fertilizer 3, it is showing a significant result here. It is showing a significant value, because 5.5 E minus 50, that means that 0.000, 0.49 zeros, 0.5. That means that it is a significant value that we can able to convert in the form of number. Actually, it is in the form of exponential value that you can able to convert in the form of general number, so that it will show you a significant result, 0.000. So there is a significant difference in 3 different fertilizers. There is a significant difference with respect to the result from 3 different fertilizers. Fertilizer 1, fertilizer 1 is different from fertilizer 2. Fertilizer 2 is different from fertilizer 3. Fertilizer 3 is different from fertilizer 1. And when it comes to the crops, there were K levels. So 4 levels: wheat, corn, soya, and rice. So when you click here, the format cells, actually it is in the form of exponential value. We are trying to convert in the form of general number. Even if you can see here, it is also showing a significant difference. Wheat crop output is different from corn output. Corn output is different from soya output. Soya output is different from rice output. So 4 different crops are different as compared to one another. So here we can interpret the hypothesis can be interpreted in such a manner from p-value approach. The p-value with respect to the type of fertilizer used, it is 0.000. It is less than the standard significant value at 5% level of significance. So that's the reason why the 3 fertilizers are giving 3 fertilizers are different from one another, and 4 crops are different from one another. So because the crops p-value also 0.000, so we can conclude that the null hypothesis is rejected, the alternative hypothesis is accepted. There is a significant difference, the type of the fertilizer used, and with respect to yield from 4 different crops. And the interaction effect, it is also one of the important parameter that we need to understand here. Even if you can see, the interaction effect also showing a significant result. The interaction effect also showing a significant result. What exactly the interaction effect? The interaction effect, it's not like this 2 plus 2 equal to 4, the 2 plus 2 equal to 5. That's what we call the interaction effect. What is the interaction effect over here? When we use fertilizer 3 with soya crop, you will get an extraordinary output. We can conclude here the interaction effect when we use fertilizer 3 with soya crop, you will get an extraordinary output, extraordinary yield from the crop. The outcome of the crop, it is an extensive manner. It's just not like 2 plus 2 equal to 4. It's 2 plus 2 equal to 6, 2 plus 2 equal to 10 also. That means when both interacts with each other, what is that? Fertilizer 3 and soya crops interacts with each other. The outcome of the output from the yield, it's extraordinary. It is extraordinary. Maximum output, accelerated output that you can able to get from, especially when we use blend 3 and soya crop, or fertilizer 3 and soya crop, you will get an extraordinary result, extraordinary output. That's the reason why even in the interaction effect also showing the significant value. At the same, like if you can see, if you can interpret the data from F critical value, if you can interpret the data from F critical value, F calculated values are like this: 138, 44, 16, and F, that's what, Z tabulated values are like this: 3.01, 2.62, 2.11. That means that the values are very far. In all situations, Z calculated value, it's greater than Z tabulated value. That means that we need to reject our null hypothesis, accept the alternative hypothesis. So there is a significant a difference, the type of the fertilizer used and output from various crops, and especially the interaction effect when we use the type of the fertilizer 3, when we go for soya crop, you will get the maximum output. Thank you.